How to Not Drown in a Data Lake. I'm your host, Ashley Peterson, and before we begin the presentation, I do have a few housekeeping notes for you. You're currently in the listen-only mode. If you experience any technical difficulties during the session today, you can click on the Help that's located at the top of your player console. From there, select the Go to Webinar Help, and you'll be able to find some options that should assist you. Also, this is an interactive session, so feel free to type any questions you have into the questions window at the bottom of your player console, and we'll be able to answer those questions during the Q&A portion at the end. I would also like to mention that today's presentation will be recorded and available to you for future playback. And lastly, we would love to hear from you, so feel free to tweet during the session today using the hashtag #DataLakeBestPractices. But before you start tweeting, let me give you a quick introduction of our speakers. First up, we have Rajiv P.S. He's the founder and CEO of Data Lakes. Rajiv has over 20 years of experience in information management, working with Fortune 1000 clients, including P&G, Bank of America, Wachovia, Apple, Gap, and Lowe's, just to mention a few. We also have with us Saurabh Jain. He's the Senior Big Data Technical Architect with Digility. Digility is a mass tech company. Saurabh has over 11 years of experience building large-scale data warehouses and data lakes globally. So with that, Rajiv, I'll turn the presentation over to you.
Hey, thank you, Ashley. So good afternoon and good morning to all of you who have joined. We really appreciate you deciding to take time to join this brief discussion. Before we get started into the topic, I just wanted to put a few things into perspective and set the context right, and why this topic or why this discussion is important at this point of time. So if you look at from a data perspective in the last 2 decades, we have seen a lot of new technologies emerging. If you start, let's start with just mainframe, and then came the relational databases. Then more sophisticated RDBMS like Teradata came into the picture. And then the in-memory capabilities got added like NetEases of the world, right? And the last 2-3 years or even 4 years, Hadoop has come as the biggest player in this whole space. And then came Spark, and now we are talking about Fling, and it's going to go on and on, right? But if you take a look at all of the large enterprises, a really close look at all of the large enterprises, everybody has added all of these technologies whenever they came into the market. So what has happened over a period of time is an accumulation of tech. A lot of new tools and technologies got added. But is the business problems really addressed? Is the business really happy? Are they really getting what they're expecting for the last 20 to 30 years? I think the answer is no. They still have no agility, right? If they want to get a new data set, they need to wait for months and months, working with many other departments, including the IT, to get some data what they're looking for. They've been asking for self-service for the last 15, 20 years. Do they still have it? Absolutely not. But one thing which has gone high, right, the cost. Because anytime you add a new technology or a tool, you are adding the license cost, you are adding the maintenance cost, the support cost, as well as the skills cost, right? So keeping this in perspective, in the context, this is another wave, this is another opportunity to take a holistic look at your entire data landscape and take a step back and use this opportunity for a transformation rather than trying to just add another piece of technology into it. So with that said, we are talking a lot about data lake or data hub, right, or data warehouses, everything. But at the end of it, what does the business really need? Assume you are a retailer and you want to create a buy one, get one campaign for your next Christmas. Or you are in the banking and want to do a risk profiling for a new segment of customers for your home loans. It could be anything of that sort. Like as a campaign manager, as an analyst, as a data scientist, you have to go find out where I can get this data from or what kind of data I need, right? Which is nothing but I need to identify the sources. Once I identify the sources, I want to understand the data, right? To take a closer look at the data. I want to see the anomalies in the data, right? What is right, what is wrong. I want to get a good sample and then play with the data. And then I want to start build my collections. I want to do some data integration. I want to do some aggregations, and I want to create a prepared data set for me to play with. And then I start analyzing the collection. And then I start germinating that insights. And visualization is something which the business is asking every day, right? They, rather than seeing something in rows and columns, they would like to see in some beautiful graphs. And after doing all this, you want to operationalize this insights. You're not doing this for just for a one time, right? Now you are doing it for Christmas. You want to do it for Easter in another 3 months. Or you want to share the same thing, whatever you have done, with your colleague sitting in the next cabin, right? So you want to operationalize that and then finally publish that and make it available to your internal users, your partners, your vendors, and anybody. But in the current scheme of things, in each of the stages, you are pretty much interacting with the IT. And each will take 2 to 3 months. So from the point when you decide to run a campaign and try to find out something, it's anywhere from 6 to 9 months before you get something out of it. And by that time, the window of opportunity might have already lost, or the requirements might have already changed, right? So the whole goal of creating a data lake or data warehouse or data hub, right? It's just 3 things. Have all the data. The business have all the data at the right time or immediately. And the business have the capability or the tools and technologies, whatever they want, to play with the data, right? So that the right agility is there for them to come up with the insights, and they can do it by themselves, right? So I really want all of you to keep this in mind, right? We have been talking about technology, we'll talk about technology, but the end goal is how business can make meaningful insights in a more agile and self-service way at a reduced cost. That's the whole purpose of whether we want to build a lake or a sea or ocean or anything, right? So now we now know that what we need to do, but at the same time, we need to do it in our context, right? It's whatever we told so far, you cannot achieve that overnight, and it's not going to happen in that way. And at the same time, you're not going to throw away all the investments what you have made so far. I mean, we talked about a transformation, but a transformation means, it doesn't mean that you're throwing away everything. It can be an augmentation to your existing capabilities, right? So you need to realize that it is a journey, and it's a long transformational journey. And when you start a journey, you definitely need to assess where you stand right now, what capabilities you have, what are your business priorities, right? You are an enterprise probably where you have data scattered all across, and you're still struggling to figure out what happened in the past or what is happening now, which is more the historical and operational kind of analytics what you need. Then if that's where you are, then that's where you need to get started with. but you are a highly innovative company and you have a lot of focus on innovation to build new products, then your focus may be to have data scientists have the exploratory and discovery capabilities to come with some meaningful insights without having a question at hand, and you're going and diving deep into the data lake, right? So you need to have your business priorities in mind, and at the same time, you need to find your low-hanging fruits as well, right? You need to start generating the value from your day one, and you need to start providing that value to your business from day one. So two things. One, keep the business in the whole context. Second, understand your priorities, understand the investments, what you can make, understand your limitations, the skills, what you have, understand that this is a journey, and then you move forward from there. Right? So putting these two key aspects in mind, I'm going to hand it over to Saurabh, who will take you through the whole framework of a data lake and the technologies, some of those aspects. And then I will come back at the end to talk a few success stories as well as a few failures. Over to you, Saurabh.
Thanks, Rajiv, for the brief insights and setting up the session. Good morning, everyone. Nice to see you guys on the webinar. Before we go through some interesting success and failure stories of the data lakes implemented across the globe, let us quickly understand what exactly comprises a data lake. Firstly, the need of the data lake arises because of the enormous volume of data generated in today's world, or in the last couple of years, the trend has been of the enormous data volume being generated year on year. Remember that we're talking about petabytes and zettabytes of data when we talk of big data. Here we will focus on key principles and architectural components for a big data lake that a business or organization should understand before planning a big data roadmap for their organization. Data lake is a central location used to store all of the organization's data, regardless of its source or format. It is typically, although not always, built using Hadoop. It can be filled with both structured or unstructured data. Now, the unstructured data is something which makes the data lake more interesting. In today's world, the unstructured data varies, and typical examples will include machine logs, articles, emails, social media logs, sensor data, RFID logs, health records, and so on. The list goes on and on. Any sort of data which was considered to be problematic or which was considered to be a challenge in data modeling for a relational world, data lake is something which can handle it without any restrictions. All such data is captured in raw format and persisted into the lake. Organizations then use a variety of storage and processing tools, typically tools in the extended Hadoop family, to extract value insights quickly and take informed key organizational decisions. The previous approaches to this based data integrations have forced all organizations into a common predetermined schema or a data model. In RDBMS, earlier the EDWs typically, data modeling was something which was done beforehand, and it used to solve some specific problems and it used to give some specific answers to the business. But it never used to handle something which used to come in an ad hoc way, which involved getting data from the source again, implementing it, processing it, and building it to the business. Unlike this monolithic view of a single enterprise-wide model, the data lake relaxes standardization and defers the modeling, resulting in an early unlimited potential for operational insights and data discovery. As the volume grows, the variety of the data grows, and as the variety of the data grows, the metadata richness also grows, which adds to the benefit of the data lake. As the picture depicts, there are some key stakeholders of the data lake. Any data lake would be not a success unless these actors are inherently made a part of its creation process. These are the data programmers. They act as a pipeline to feed the data lake. Their primary responsibility and ownership should be only to get the data from various different data sources into the lake and make it available for reporting analytics as quickly as possible without having to think on how the data will be used by the analysts, management, for reporting and analytics purpose. They don't have to worry about model schema of the captured data. Their only focus is to get the data into its raw format as it is as quickly as possible into the data lake. Next is the data scientists. Data scientists, they use the data lake for discovery of hidden information from the raw data. They use wide variety of tools on top of the raw data and apply different types of algorithms to extract meaningful insights like patterns, anomalies, frauds, recommendations, etc. that can help business take some important growth decisions quickly in a competitive market. So this is what conceptually a data lake comprises of. Now let's go through some of the major pillars of the data lake. These are the key pillars most organizations consider before stepping into the data lake, and this is something which we strongly advise organizations to consider before defining a roadmap for their organizations. First and foremost is the cost and the low cost and the size of the data lake. Considering the economies of scale, some organizations claim they pay less than $1,000 per terabyte for a data lake. Yes, you heard it correctly. $1,000 per terabyte for a data lake. Although the numbers can vary a bit, but because it's no longer excessively costly for them to store all their data, they can maintain copies of everything by simply dumping it into a data lake to be discovered and analyzed later. This is something which is very important for organizations to remember. Earlier, storage was a problem. The storage was costly, and hence organizations used to consider twice before defining their requirements as to what data is critical, what needs to be stored, and which should be used for reporting. But with Big Data Lake, they can maintain copies of everything, even if that data doesn't have any sort of analytic requirements, any sort of reporting requirements. They can still maintain copies of everything by simply dumping it into the data lake. Big data is typically defined as an intersection between the volume, variety, and the velocity as the typical 3 V's of the big data. EDWs are notorious for not only being able to scale beyond a certain volume due to the restrictions of their architecture. Data processing takes so long that organizations are prevented from exploiting all their data to its fullest extent. Using data lakes, petabyte scale data lakes are both cost efficient and relatively simple to build and maintain at whatever scale is desired. So these are some important points related to the size and the low cost. The next is the fidelity of the data. Within EDW, if the data has undergone, typically EDW involves transformations, aggregations, updates, derivations, and so on. Okay. So if the data has undergone some sort of transformations, aggregations, and updates, most organizations typically struggle to piece their data together when the need arises and have little hope of determining the clear provenance. Basically, it impacts the question of the data lineage. Data lake preserves the data in its original form and captures changes to the data and contextual semantics throughout the data lifecycle. The approach is essentially useful for compliance and internal audit. It helps organizations tremendously in terms of the compliance and the audit requirements, where the questions arises from a security constraint as to what has changed, how it has changed, and what was originally being captured. The next important pillar is the easier accessibility. Data lakes solve the problem of data integration and accessibility through that plagues the EDWs. Using the big data lake infrastructures, you can bring together ever larger data volumes for analytics, or simply store them for some as yet undetermined future use. Unlike a monolithic view of an EDW, the data lake allows you to put off modeling until you actually use the data, which creates the opportunity for better operational insights and data discovery. The advantage only grows as the data volume, variety, and the metadata richness increase. Just imagine not going through any SDLC process. So you have all your raw data captured as it is in the data lake, and the management comes and says, I want this report, I want this analysis, and it should be up and running in quick time. No change requirements, no SDLC process. Just the requirement goes to the data scientist and it should be able to access the raw data, build some algorithm, and able to get the insights out of it. So we are talking about reductions from months to a few days or maybe a few hours in order to meet your ad hoc analytical needs. Last is the secured and the late binding. When we store the data in an EDW, it works well for certain kind of analytics. But when we are using Spark, MapReduce, or any other new models, preparing data for analysis in an EDW can take more time than performing the actual analytics. In a data lake world, data can be processed efficiently by these new tools without excessive preparation work. Integration involves fewer steps because data lake doesn't enforce a rigid metadata schema. So here we are talking about moving away from schema on write approach and going into a schema on read approach, where the analytical reports or the requirements of the business defines what schema you want from the data. Because data can be structured as well as unstructured, you can store everything from blog postings to product reviews to social media to machine logs and so on. Data doesn't have to be consistent to be stored in a data lake. Data definitions, the handshakes of the data doesn't have to be stringent. It can take any form. Even if some attributes are missing, it can still be persisted into the data lake. This would be problematic in an EDW. In a data lake, however, you can put all sorts of data into a single repository without worrying about the schemas as well. Now, understanding what are the major pillars of the data lake, let's have a quick glance over what exactly would the data lake ecosystem comprise of. So here we see a reference architecture of a data lake ecosystem. Data lakes created with an integrated data management frameworks eliminates the costly and cumbersome data preparation process of an ETL that traditionally EDW requires. Data is smoothly ingested into the data lake where it is managed using metadata tags that help locate, connect information when business users need it. We have created this reference architecture that incorporates the best practices for the data lake building and operations under a data governance framework. The main advantage of this architecture is the data can come into the data lake from anywhere, including online transaction processing logs, operational data stores, logs, machine data, cloud services, or any streaming source. The source systems include many different formats such as file data, images, database data, ETL, batch files, streaming, and so on. In fact, coming through different APIs as well. The architecture is quite simple. The data is first loaded into a transient loading zone where basically data quality checks are performed using some MapReduce components of the big data cluster. Once the quality checks have been performed, data is loaded into Hadoop in a raw data zone, and sensitive data can be redacted so it can be accessed without revealing personally identifiable information, personal health information, payment card industry information, or any other kinds of sensitive or vulnerable data. Once the success has been there on capturing the raw data and storing it necessarily, data scientists and business analysts alike dip into this raw data zone for set of data to discover. An organization can, if desired, perform standard data cleansing and data validation methods and place the data in this trusted zone. This trusted repository contains both master data and reference data as well. Finally, the consumption zone exists for the business analysts, researchers, and data scientists to dip into it and do what-if analytics, and otherwise consume the data to come up with some business insights of informed decision making. Now, understanding what a data ecosystem looks like, let's go through some of the technology enablers in terms of what this data lakes will look like. Whenever we hear about data lakes, we typically associate it with Apache Hadoop. Apache Hadoop definitely is the core part of the big data architecture, but there have been several distributions in the market which also offers the expertise of the Apache Hadoop. Some of them includes Mapr, Cloudera, Hortonworks, GoPivotal, and so on. They are all being managed by different private organizations, but functionality being offered by them is pretty much common, and it should be used on a per requirement basis by the organizations. Here we see on the data ingestion side of it, on the data processing side of it, on the visualization side of it, there are so many components available. So the challenges organizations face is which is the right component. Most of the open source components are meant for a precise use. We will hardly find components which are reinventing the efforts done by a separate component. Looking at the data ingestion part, there are components like Flume, Scoop, Apache Kafka, Spark, and Storm. These are some of the key components which are used and which can source data from any of the source systems and can bring the data into a data lake, which is the Hadoop storage area. Once the data is into the storage area, the Apache Hadoop, there are many processing and analytics frameworks available, like the MapReduce framework, the Mahout, Apache Spark, Flink, as Rajiv said earlier, Apache Kudu, and so on. These are the frameworks which provides distributed capabilities on top of your data lakes. They run their processing in parallel in the distributed manner, fault tolerant and scalable way, so that you can get the business insights, the trends, the patterns, and so on quickly in real time. Once the data has been analyzed, it becomes very important to give this data in a much more readable manner to the business or the analyst or the management and so on. That's why there are many components on the data analytics visualization side where we have Apache Drill, Zeppelin, Tableau, ClickView, Spago BI, and Kibana, and so on. They provide a capability of mapping the raw analyzed data into a much better presentable framework. So these are some of the technology enablers on the processing side of it. There are some frameworks components also available on the monitoring sides like the Apache Ambari, Cloudera Manager, Mapper Control System, which provides you the capability of monitoring or a complete data lake as a platform. Most important thing is the security. So there have been components like Apache Ranger, Sentry, Kerberos, which provides a very tight security when somebody wants to access your data lake. So it proves very important from a perspective of the data governance that such components are available in order to manage the data lake. They are still naive, but they are building up and they are providing good data governance capabilities. Now, having known the technology enablers, let's go through the next slides, which will be understanding some of the key success and failure stories. So working with a lot of organizations, what we have tried to do out here is we have put the best practices and we have also put down what exactly worked for some of the clients, what did not work for some of the clients. And this is where a key takeaways will be for the session. Let's talk about one of the examples for the Indian National Bank, one of the success stories. The bank used the IBM's proprietary tool for their EDW systems. Even though the tool is good for the EDW capabilities, the problem started when the customer base grew and the volume of the data started increasing. The bank was not able to roll out campaign offers in real time to the customer, leading to a lot of expired campaigns being targeted to the users. The access to this campaign was obsolete and hence resulting into a loss to the organizations from an end user perspective. So first thing first, the goal of the organization was very clear. They wanted a data lake for a real-time campaign analytics. When they set a data lake, it included data for all real-time campaign data, which involves the transactions of the customers, their social media behavior, their net banking behavior, the campaigns which were targeted to them, the campaigns which are going to be targeted to them. So it was not only about the campaign data itself, but all the data associated to the user which can impact the campaign acceptance ratio. So the goal was pretty clear. The business was involved. The business was being told about what is to be done and what will be the achievement post the data lake implementation. So it becomes very important you take the business together when you are going for a roadmap for your data lake. So post implementing the campaigns to the customer, the benefits that were achieved were the targeted campaigns to customer were sent real time. When we say real time, so there was a delay of as good as 15 minutes, as opposed to a lag of 7 days from the EDW. So that's a big improvement in terms of the throughput or in terms of the latency that was being achieved via the EDW. Secondly, there was an 11.5% increase in the click-through conversions of the user-targeted web campaigns. The campaigns which were obsolete earlier, now the same campaigns became valid, and there was a growth of 11.5% increase in the conversion ratios. So people were applying for loans, people were applying for the campaigns, home loans, personal loans, and so on, which was earlier being obsolete, considering that there was a lag of 7 days and the rates have changed. As the data was growing, the infrastructure was also growing, resulting into no upfront investments in hardware, thereby resulting into a considerable savings in the infrastructure. As the Big Data Lake provides a scalable infrastructure, there was no upfront cost involved, and as and when the data was growing, new servers were added, and it resulted into much huge benefits in terms of investments. Next was the main criteria in terms of or advantage which was achieved was there was a 40% reduction in IT team to manage and monitor the system as compared to the EDW system. What advantage Data Lake gave was there were no data processing capabilities required in between. There were no data transformations required in between. There were no extra support team required in order to manage or monitor the cluster. This helped the organizations to reduce a manpower of by 40%, resulting into a considerable saving in terms of the expenses. Another advantage which the organization achieved was there were multiple systems like the CRM systems, their net banking systems, their own real-time loan systems. So all these systems were now able to interact with the data lake via APIs, and they were able to get the real-time data and achieve a single source of truth, which was earlier not possible. Lastly, since it was a banking system, it was very important to comply towards the audit compliance as well. That's where data lake provided the inherent or implicit advantage of processing and preserving the entire, right from the raw data to the processed data to the aggregates, and thereby providing a complete data lineage of what was captured and what was achieved. So in all, the good thing was the organization was able to achieve their targets with tangible outputs which can be measured. Now, having given you an example of success story of an Indian National Bank, I'll hand it over to Rajiv, who will walk you through some of the global implementations of the data lake and where it has been a success and a failure and so on. Rajiv, all yours.
Thanks, Saurabh. So let me talk about one more success story. This particular client we are talking about. It's a large money transfer firm. That organization let people transfer money from one country to another through various channels. And this particular client had agents across the globe, around 30,000 plus agents. And when I say agents, these are either the large retailers, it could be some mom and pop shops, or it could be even some individuals. And these agents transact the money through our client's platform on behalf of our client, and they receive a certain commission, preset commission based on the targets achieved. So at the end of each month, our client has to send reports of either the closing summary report, the daily transaction report, the commission summary report, and for certain compliance purposes, they have to send certain reports as well to all of their agents, to the 30,000 agents across the globe. And traditionally, they have been sending large PDF kind of reports, which had 500 or thousands of pages. And you can imagine any of this, say for example, take this large retailer, one of their agents, right? They're not going to go through this 500 pages of reports. So for any reconciliation, any clarification, they call our client's call center and they get all of their questions answered. And the call volume was huge because all the reports, what they've been sending out by our client, that's not been used at all. Right? So this was the problem statement. And for this, we built the data lake. We put all of this data into the lake and provided all of these agents. So 30,000 agents, and each of those agents will have multiple hierarchies, right? Their regional managers, their store managers, and so on. All of them access to the data, and they were able to interactively engage with this information in a very secured way. And they were able to do the analytics of this data provided through this data lake. And it's all managed based on groups, their organizations, and it was all given based on the hierarchies of the customers, and it was well secured. So the result of this is that the number of calls going to the call center of our client at the end of the month went way low, and they were able to realize at least a 30% of cost just in managing the call center. Even if they call the call center, they still have the same interface to go through the data and then provide or answer the questions. So there is no point in their agents calling the call center and wasting their time, right? So that was a huge benefit of implementing a data lake. Now that they have this capability of a data lake, they started adding new value-added features. A couple we recently added. One, they were able to enable gamification between their agents. So they had different slabs of incentives based on how much money they transfer on behalf of their clients. And they had real-time visibility to where they stand at a given point of time. And they enable this gamification in a region of their agents and created that competitiveness, and they incentivized based on the model they established for this gamification. Another capability which was added is this data lake was able to get large public data sets, say for example like census data. Census data provides information about the demographics to a block level. And if they had to run a targeted campaign, so if you take an example of this money transfer happens to other countries, and that depends on if they have parents or grandparents living in another countries, if there is a festival season in a country, or if there is some specific game happening in a country, the money transfer will vary based on that. So they were able to get this census data superimposed on their sales data and their potential clients, and they were able to run targeted campaigns and discounts to facilitate more money transfer in a specific time frame based on some of those parameters. So in that way, they were able to increase their customer engagement. They were able to increase the volume of transaction as well as the bottom line from this. So though the data lake, the initiative started with a improved experience for their agents, now they are able to enable additional value-added features, and data scientists are continuously working on this data lake to come up with new products, new ideas to have more customer engagement or more gamification. Now that we heard two different success stories and what made it successful, let's also talk about a couple of failed initiatives. And I don't think we get a lot of opportunity where we hear failed initiatives because nobody wants to talk about failures, right? But I think it is equally important to know that why certain initiatives are getting out of control and falling through the cracks. So the first one, where it's a leading bank, a retail bank, in their risk department, they were using Teradata as their enterprise data warehouse and MicroStrategy as their reporting tool. And when this was around 4 years back, when Hadoop was at its height, they decided to run an initiative to reduce the cost of Teradata, because we all know that it exponentially rises as the data volume increases. So they decided to take as much as data possible off of Teradata and then move into Hadoop. And the key goal they have set is cost reduction. They didn't look at how the business is going to benefit out of it, what value it is going to add for the business. They didn't look at any quick wins or low-hanging fruits, but that they ran an initiative for almost 2 years. They built more than 200 node clusters. They started moving data off of Teradata into Hadoop. And at the end of 2 years, the business is asking, what did I get out of it? There is absolutely no business value. It was purely run as an IT initiative. And the whole thinking that it will bring the cost down, that was also not true, because building a 200 node cluster and managing it, it's not that easy. So though the hardware costs were very low, but managing those clusters and maintaining that, building that skills, that really was more cost than managing the Teradata. So the point I'm making is not that the cost reduction is not possible. It is definitely possible over a period of time, but nobody will have the patience, or the business will not have the patience to wait more than 2 years to see the value. And if you're not starting with a business value upfront and demonstrating that value in 3 months, if not in 6 months, if not in 3 months, then your initiative is going to get stalled and it will be a complete disaster. The same client, now they are taking a pause, they are revisiting all what they have done. They're starting all over with a top-down approach of putting the business first, the business value first, and then doing it all over again with a clear 3-year strategy. The second example, to give another perspective or a potential cause for failure. This is a retailer. When this big data initiatives, the tools and technologies came up, the leadership let all the various departments or line of business to run their own initiatives. So the marketing department, the finance department, the purchase, they all started building their own small Hadoop clusters. They started creating copies of data into their clusters. It's more of duplicates. And they started creating more and more silos of data. The governance, as Saurabh said, that fall apart completely because nobody knew what data is sitting where. Each department started to come up with their own interpretations of the data. No common metadata was there. And at the end of it, even the financial reporting started falling apart because there is absolutely no control. The lesson learned from there is a clear vision has to be set from the leadership with, again, the business goals in mind. And the whole organization has to align that with that vision, and it has to be managed in a centralized way to avoid silos of data, keeping the whole data governance in control right from the beginning. So now that we saw few successes and few failures, a few takeaways for you when you go back to your organizations. First and foremost, any big data initiative, any data lake initiative you start, make sure you have a tangible, measurable benefits. Even if you are doing a POC, it could be a 2 months POC, it could be a 3 months POC where you want to try out a small Hadoop infrastructure, a small capabilities, but your focus has to be how you can create a small use case and provide value for the business. Never ever run it as an IT cost saving initiative. The cost may be even more, just like in one of the examples which we saw, right? If the focus is just to save cost from an IT initiative, don't project it in that way. You will start seeing the business losing the interest, and the initiative will be stalled in no time. There will be advantages from an IT perspective, right? You can use this as a data archival, easy accessible archival platform. You can have an analytical platform to play with a lot of historical data. All this additional capabilities, the cost saving capabilities, initiatives you can run, but put the business requirements or the business value in the front. Always start small and iterate. Just like in one of the failures we saw, they didn't want to realize any value for first 2 years. They were running it as a 2-year initiative, and they started thinking about measuring the value at the end of 2 years. But technologies are evolving every day, and the business requirements are changing. So make sure you start small, generate business value at each step, and then you keep iterating, but have a vision in mind, right? At the end of 3 years, what do you want to achieve? Keep that goal in mind. It could change slightly over a period of time, but have that end vision in mind, but start small and iterate. The other thing what I see here from a lot of customers is, let us get all the possible data in, and the rest we will figure out. In my mind, that's an absolute no. Again, without having a top-down approach on why or what you want to do, and then work backwards from what data you want, and then start bringing the data, I believe that's the right approach. The counter question which people have asked me is that, what if you start seeing new varieties and volumes of data? Very valid question. But as we talked earlier, keep that long-term vision in mind. You're creating a framework of a data lake with a clear future in mind. So anything new, almost 80% your framework should be able to accept new types of data, new volumes of data, new requirements. But don't think about just filling your lake with all the data. Keep the business requirements first. Coming to data governance, I know Saurabh talked about that a bit when he talked about the architecture. Right? Each and every capability you add, you have a tick mark on your data governance checklist. It has to be there. With the traditional data warehouse itself, we are struggling to keep track of the data and to keep the data in control. So now we are talking about a data lake where we have large volumes of data, varieties of data, and more access, more self-service. Governance is going to be the key. And you need to start thinking about it now. Otherwise, in 3 months, you will not have any clue on what data, who is seeing, and who is using what data. Last but not the least, have a plan on the metadata. Even in the last 5 to 10 years, we are hearing about metadata management, having a business glossary, a data glossary, or a data dictionary. But still, with the traditional data warehouses and mechanism, we are still not there to have an enterprise-wide metadata management plan. And now we are thinking about ingesting lots of data into the lake. And if you don't have a proper metadata available for the business, there is no analytics or analysis they can do on this data. Right? They need to know what this data is about. And the industry or the capabilities are yet to get matured on finding the metadata after it is ingested. A lot of AI or intelligent capabilities are now being generated, but it will take a year or two to get matured on that. So we still need to have a close look at how the technologies are evolving in capturing and managing the metadata in a data lake. But at least put that also one of the key items, just like your governance, in perspective while you are building the data lake. So how do you measure the success, right? I mean, we have heard a lot of our clients, I hate to use this term, but bragging about their success in data lake or in big data by mentioning that we have 200 node clusters or 300 node clusters. In our mind, success is not in the number of large clusters, but it's about the value you have delivered to the business, how it helped improve my top line, how it helped improve the experience to my customers, how it helped reduce my operational cost. It's all about the value we are providing to the business, not in adding large number of clusters. So with that said, I will turn it back to Ashley for the Q&A.
Thank you, Rajiv. Yep, so at this time, I'd like to now open the floor up for any questions. And as a reminder, you can type your questions into your questions window on your player console. So we did have a couple of questions that came in during the session, so I want to grab those first, and then as they come in, we'll start reading those as well. The first one that came in was, you talked about a failed initiative at a bank who created 200 nodes of clusters, etc. What would you do different in a similar situation?
Thanks, Ashley. It's a great question, and one of the initiatives what we are working on as we speak with one of our clients, they have a same scenario where they approached us with the same thought of moving off of Teradata and reducing the cost, running it as an IT initiative, right? What we did is we went and we are now working with their business to understand what they are, it's a retailer, and what they are trying to achieve from a business perspective. Or is there any business priorities set for this year? One thing which came out is they're running a program for improving the customer engagement. And one of the areas which they picked is to analyze how their coupons are performing in their market. Right, so this coupon data is sitting with the third-party agency for this retailer. Some of their customer data is again managed by another third party. We identified a use case on how this coupon engagement is happening, like the VTC and the CTC, the view through conversion, click through conversion. We took that as a use case and put that in the front while we started building this data lake. So it all started as an IT initiative to reduce the cost, which is still on the way, but the whole initiative is run as a customer engagement initiative, and there's a solid use case identified, and the value will be delivered to that program, the customer engagement program, in the first 3 months with a simple use case. So to the same point, it's about how you reposition this whole initiatives, have a value you can deliver to the customer in 3 months or less, while your roadmap is to build an augmented data warehouse infrastructure, and you can take your data off of Teradata, you can do all those good things. So this is how we have changed after learning from the mistakes what we have seen so far. Ashley?
Thanks, Rajiv. Yeah, so we had another question that came in, and it was along the lines of, why are you not discussing data governance and metadata management? And it says even though it is about avoiding a data swamp.
Okay, so data governance is an important factor to be considered, but the core focus when setting up a data lake is to ensure all the raw data is being captured effectively into your system. Of course, data swarms, we're not going to create that. That itself, when most of the organization starts, they try to create small data ponds where they see that, okay, we have a marketing requirement, we have an advertising requirement, we have an IT requirement. Okay, so what they try to do is each organizations, be for a political reason or for their own IT department or for their own setups, they try to create small data ponds which they capture the data. But over a period of time, what happens is they are resulting into data duplicacy, data replications, data one source of truth also gets nullified. That's where it's important to ensure that the first and foremost principle of getting your data lake built correctly, rather than going into small setups where you ensure that, okay, it's it's a marketing requirement, you build a governance on top of it so that no advertising tries to access that, or you try to build it for an IT department so marketing is not able to access that. So it may result into a successful data governance, data ponds, but as an overall data lake perspective, you might start seeing disadvantages when you're able to get different reports out of this data ponds. So data numbers out of those analysts will not match. The data reconciliations will again be a problem where you will not be able to tie the numbers between these sources of data. Once you have built your data lake where all the data is being captured in a raw format, consistent way, of course, there are mechanisms where you can concise or you can build governance on top of specific sets of data where the teams will not be able to access each other's data. When I say this being observed from a single data lake as opposed to building small data ponds. But that is something which is an important factor, but it comes not in the early phases of building the data lake, and it is surely an important factor, and it is being considered while building a data lake in order to ensure that the data is being given to the analysts or the business or the scientist in an effective manner, and there is no uh, crossing the roads of each other's data. I hope that answers the question.
If I can just add to that, Saurabh, right?
Yeah.
One thing what we see is, what we all know is governance as well as self-service, right? Those two are really conflicting needs or demands, right? If you put, governance is in one way people look at it is to put more restrictions, but self-service is to get as much as access to anything what I want, right? So how you manage that or address that in an optimal way, right from the beginning, that's the key thing. So I don't know if there is a right or wrong answer or a one-liner which will solve all of this problem, but we need to manage that from an organization to organization perspective, right? And then build that technology and capability around that.
Okay. I'm going to try to squeeze in one more question. I know we're getting close to the time allotted for us today, but we had a good question that came in just a few minutes ago that was, what are the typical timelines to implement a data lake in your experience?
Okay. Let me take that, and then Saurabh, you can add if there's anything. Right. Again, this is going to be a journey, as we discussed in the beginning. Right. It's not like you go with that. I want to build a data lake in 1 year, or I want to build a data lake in 2 years. I don't think you can go with that approach. But you're going to create a framework which will have a 3-year in mind or a 5-year in mind, right? And then you're going to start small and then build on it. So when the way how you, it depends on the way how you want to measure the success, right? Just like we said earlier, if the measure of success is in looking at how much terabytes or petabytes of data I put into a data lake, then it can be done in maybe 6 months or 1 year, right? But if the way how you want to measure is how the business is getting the value each 3 months or 6 months, then you have built a lake in 3 months too, right? So it depends on how you want to measure the success. But overall, any program will start with a 3 months proof of concept. That's what we have been into, and then get into a pilot mode for another 3 months, and then keep adding capabilities. So most of the programs which we have engaged so far, it's running up to 2 years or even more. And during this period, we all need to understand that the technologies are changing, new components gets added, and it's going on. So it's start with a 3 months, very small POC, but it goes over 2 years and more. Saurabh, is there anything you want to add?
No, yeah, I pretty much agree with Rajiv here. Just to add a small line is, it's an evolving process. So as we discussed earlier, organizations nowadays are dumping the data even though they don't see immediate analytical or reporting needs. They do not know what is to be done, but since the storage is cheap and it's built on top of commodity hardware, so organizations are just dumping the data to be analyzed for later use. So that's where it's important to realize as to the data they keeps on growing, but there's no definition as to what's the correct lifetime to be implemented. It's an evolving process. The new data keeps on coming, the variety of the data changes. As Rajiv rightly said, the components changes. So the goal should be to capture the data in the raw format and bring it to the data lake and persist it. The data is like the oil in current generation, and it is definitely going to be helpful for the future analytical purposes. I hope that answers the question. Ashley?
Yeah, I think so. I think that was very helpful. So, and I know we are over our time, so I'm just going to conclude the Q&A session, but I'd like to mention that if anyone has any additional questions, please feel free to type them. Email us over at info@digility.com. I know I have access to that myself, and I can pick those questions up and send them directly to Rajiv and Saurabh, so I can get those answered for you right away. And for that, I would like to thank our speakers today, Rajiv and Saurabh. Thank you for taking the time out of your busy schedules, to be here with us. And also a special thank you goes out to you, the audience, for spending the last hour and 3 minutes with us. We hope this session was informative and that you can use some of this information, that you've heard today, both the successes and the failures, in your big data initiatives. So with that, I'll conclude the session. And again, Rajiv, Saurabh, thank you very much.
Thank you, everybody.
Thank you, everybody. Thanks, Ashley. Thanks, Rajiv.